Hello everyone, welcome to our course on fluid mechanics. So this will be the introduction. In this video we'll cover what is fluid mechanics, branches of fluid mechanics, and why is fluid mechanics important. So we'll start with what is fluid mechanics. So we'll start with the basic concept, which is what is a fluid. So a fluid is a substance that can flow. So we know the liquids can flow, gases can flow. So liquids and gases are together called fluids. Now, what is fluid mechanics? So fluid mechanics is a branch of science and engineering that studies the behavior of fluids, which means that studies the behavior of liquids and gases. Now, in fluid mechanics, we study fluids at rest and we study fluids in motion. So we can say that fluid mechanics is the branch of science and engineering in which we study liquids and gases both at rest and in motion. Now, what are main branches of fluid mechanics? Now, there are various branches of fluid mechanics. The basic one is called fluid statics. In fluid statics, we study everything about fluids when they are at rest. So when air is at rest, so air can be at rest when air is suppose in a container, is enclosed in a container, that is like air is at gases are at rest, or liquid is in a container, so liquids at rest. So in fluid statics, we study everything about fluids when they are at rest. For example, water in a tank, pressure in a dam, or oil in a container. So these are the things that we study. In fluid mechanics, the basic concept is the pressure. So we mainly study about pressure forces on various bodies. When a body is fully or partially immersed in a liquid, what are the various pressure forces acting on it and all that. And based on that, we design various bodies when they are submerged in a fluid at rest. Like, for example, a body is placed, a ship is placed in a sea or ocean. So when it is at rest, it still is acted upon by various pressure forces, so we study all those forces in order to fully design the ship. Now, another branch is the fluid dynamics. Fluid dynamics means study of fluids when they are in motion, and fluid comes in motion through various forces. We study various forces in fluid dynamics, and what are the various forces that are acted upon, that act on fluids and that cause fluid to move. What are these various forces? So all these we study in fluid dynamics. Now, some authors call fluid mechanics itself as fluid dynamics, because when they talk about fluid mechanics and fluid dynamics in the same sentence, it means they consider the whole subject as fluid dynamics, because they consider statics as a special case of fluid dynamics where velocity of the fluid is zero. So we can call fluid mechanics as fluid dynamics. Means in that meaning, we have to keep in mind that they consider fluid statics as a special branch of the fluid dynamics when the velocity is zero. So fluid dynamics means like water flowing in a pipe, or air flowing on an airplane, or blood flowing in our arteries, breathing, air flowing during breathing and all that. These are some examples of fluid dynamics. Now then we have something called fluid kinematics. Now, in fluid kinetics, this is another branch of fluid mechanics in which we only study about the description of fluid. So, when we want to describe a fluid, all that is studied under fluid kinematics. So, we want to know how the fluid is moving. So, when we want to study only about how the fluid is moving, we call it fluid kinematics. So, how the fluid is moving? It is moving at constant velocity. Is it accelerating? How the fluid is moving, we study it under fluid kinematics. In this, we study various fluid flow visualizations. For example, how the air is flowing in this room. What are the air patterns? So, for example, we will generate smoke, and since air is invisible and we generate smoke, the flow pattern of the smoke will tell us the flow pattern of the air. So these flow visualization technique is the study of only the velocity, the acceleration, the displacement, these things, not worrying about the forces that cause those velocity changes or accelerations. When we only are concerned about the description, the velocity, the acceleration, the flow patterns, we call it fluid kinematics. Then we have another branch called hydrodynamics. Now, hydrodynamics is a special branch of fluid dynamics in which we study about liquids. We study about liquids and gases at low speeds. So, liquids are generally incompressible. They are incompressible, and gases are also treated as incompressible when they are moving at low speeds. So we call this incompressible flow. We call this type of flow as incompressible flow. Now, study of incompressible flow is called hydrodynamics. Now, there is a subcategory of hydrodynamics called hydraulics. Hydraulics means study of purely liquids, not including gas at low speeds, study of purely liquids in pipes or open channels. So, study of liquids in pipes or open channels is called hydraulics. So, what we know what is a pipe. Now, what is an open channel? Open channel means a channel that is open to atmosphere, but not necessarily open to atmosphere. This is the common definition that we remember for the open channels. So this is a channel. Suppose water is flowing in it. It is exposed to atmosphere at the top. So this is an open channel, but an open channel flow necessarily does not mean one of the surface has to be exposed to the atmosphere. For example, this is a pipe, and if this pipe is fully filled with liquid, we call it internal flow. But if it is not fully filled with liquid, but half filled with liquid or partially filled with liquid, such that there is a free surface of this liquid when it is flowing. So when it is fully filled with the liquid, it's internal flow. When it is partially filled with the liquids, there will be free surface inside the pipe. This is also called open channel flow. Open channel flow. So hydraulics is the study of only liquids in pipes and open channels. Now, another branch is called gas dynamics. Gas dynamics. Gas dynamics is the study of compressible flow. So, hydrodynamics is the study of incompressible flow, and gas dynamics is the study of compressible flow. In incompressible flow, during the flow, density does not change or changes negligibly. So, but when during flow density changes by any mean, when density changes, whether it is due to temperature change or whether it is due to high speed, If density changes, if density change occurs during a flow, we call it compressible flow, or we call it gas dynamics. So compressible flow is also known as gas dynamics when density change are significant, when density changes so much that it affects the fluid flow. We called it gas dynamics. There's also subcategory like the hydrodynamics. There is subcategory hydraulics. In gas dynamics, there is a subcategory called aerodynamics. Now, aerodynamics is the study of mainly air when it is flowing over bodies. When air is flowing over bodies like airplanes, airplane wings, or rockets, or cars or automobiles, we call this special type of gas dynamics as aerodynamics. These are the various branches of fluid mechanics. Now there are other specialized branches like meteorology. It's a specialized branch. Meteorology, it is the study of atmosphere and weather. Now then there is oceanography, which is the study of flow in the ocean and all that. So meteorology, oceanography, these are the studies of natural flows, we can say. Then there is hydrology. Hydrology is the study of water that is on the surface of the earth, or the hydrological cycles that goes through the hydrological cycles. We call that hydrology. Like there is water in the seas, oceans, it evaporates, then a condensation occurs, that it falls back on the surface of the earth. When it falls on the surface of the earth, it either can go inside the earth or flows over. The part that flows inside the earth and becomes the part of the groundwater is called infiltration, and the part that flows over the surface is called a runoff. And the study of all this is called hydrology. So these are the various branches of fluid mechanics and these specialized branches. And then moving to why is fluid mechanics important. Now fluid mechanics is used in many fields, in many real life applications, like breathing, the air that we breathe. It is governed by the laws of fluid mechanics. Then there is blood flowing inside our blood vessels. That's also an application of fluid mechanics. Then there is, for example, swimming, when we swim inside the water. So we have to remember that the study of fluid mechanics is not just when fluid is flowing over a body. When fluid is flowing, it also includes when fluid is flowing over a body. That's also the fluid dynamics, or fluid in motion. Or fluid can be at rest and body can move inside this static fluid is also the fluid dynamics. For example, airplane flowing through the air. Air is more or less static. But when airplane is moving through this air, it is like a body moving through the static air. So we since motion is relative, we can think it up as the body is stationary and the air is flowing on the opposite side on the body. So this is also the fluid mechanics. So when we go for swimming, even though the water is at rest, but if we think about it relatively, so we can say we are at rest, moving our legs and hands, and water is flowing on us in the opposite direction. So swimming is another application of fluid mechanics. Now we have pumps that increase the pressure of liquids. They are designed on the laws of fluid mechanics. We have fans, we have turbines that generate rotational power using the energy from the moving fluid. Then we have airplanes moving through the air, another application of fluid mechanics. We have ships moving on the oceans, again application of fluid mechanics. We have flowing rivers, we have pipelines, the pipes in which water is flowing, another application of fluid mechanics. We have jet engines moving through the air, we have sprinklers. Basically everything in this world is either a fluid or is moving through fluid or is affected by fluid. That's why the subject of fluid mechanics is very, very important. In order to understand fluid mechanics, we use both, that is the theory and experiment. Now, studying theory means using the basic laws of physics, like the law of conservation of mass, law of conservation of energy, law of conservation of momentum. We use these laws and we generate some equations, and that we can solve simply using pen and paper, and we can reach to the conclusion, and we can predict the things using those equations. This is called using the theory. But the subject of fluid mechanics is very complex, and most of the fluid problems are complex, and we cannot use the theory alone, because theory is developed using three important tools of science, which is the assumptions, approximations, and idealizations. So when a system is studied, approximations are made, assumptions are made, idealizations are made, so that the system is made as simple as possible, so that we can apply our basic laws of physics, and we can develop our differential equations. Now the results are hidden inside these differential equations, so in order to get to those results, we have to solve these differential equations. Now solving these differential equation is where the complexity comes in fluid mechanics. Now for simple cases, we can solve these differential equations, and when the fluid problem is more complex, geometry is complex, geometry is not simple, we cannot solve these differential equations, which are basically partial differential equations. So we can only solve them for simplified cases, under idealized cases. So we study theory to get understanding of various mathematical equations. So that theory is developed for simplified cases, but since most of the practical problems are complex, so we have to go for experimentation for those cases. So in fluid mechanics, theory and experiment go on hand to hand, and there is actually a third way of studying fluid mechanics that is relatively recent. That's called CFD, computational fluid dynamics. What we do in here is that we use today's powerful computers, and we can solve these partial differential equations using these computers, using today's software like NSYS, like COMSOL, and many other NSYS Fluent, many other softwares that we can use to solve these complex equations on computer. And this way studying fluid flow problem is called computational fluid dynamics. So in today's lecture, we learned that a fluid is a substance that can flow. We learned that fluids include both liquids and gases. Fluid mechanics studies the fluids at rest and in motion as well, and it has many practical applications, and important branches include the fluid statics, fluid dynamics, fluid kinematics, hydrodynamics, hydraulics, gas dynamics, aerodynamics, and there are specialized branches like meteorology, oceanography, hydrology, etc. And we learned the subject of fluid mechanics cannot be understood fully by theory alone. We have to study the theories, the experimentation, and the recent way of studying fluid mechanics, which is using powerful computers, which is computational fluid dynamics. So whenever studying a fluid mechanics subject, we will study theory, we will study experimentation, and we will study the what's called computational fluid dynamics as well. All the three go hand in hand. So thank you for watching. In the next lecture, we are going to start with the most basic concept is what is fluid in technical sense. I introduced the fluid. What is fluid? That's something that flows, but there is a formal way of defining what is a fluid, and we are going to start with that. Thank you.